Hi, good afternoon, everyone. Thanks a lot for joining us here at the Unit8 Talks. For those of you who are here for the first time, Unit8 Talks is our series of webinars related to data and AI, where we're sharing some of our experiences and some of our knowledge. The topic for today is actually around improving overall equipment effectiveness, so OEE with advanced analytics and AI. So as you can imagine, it will be focused on the manufacturing sector. And this particular webinar belongs to the Unit8 Talks on business track. So we're going to be focusing more on the business side, although we'll give you a sneak peek of what's under the hood with regards to the technologies that we're using. My name is Kamil Zalewski. I'm the AI practice lead of Unit8, and I'm also running the growth of the company. Together with me, you have Tomek Hudzik, who's our engagement director, and who's also a key architect behind some of our key deployments and key solutions in the manufacturing sector.
Hi, everyone.
Hi. For those of you who are new to Unit8, what is it that we do? With a Swiss data and AI services organization, actually focused on helping the more traditional type of businesses close the gap between the data and value. And we're doing that by driving the adoption of data science, of AI, of machine learning, so that the companies can start treating their data as the business asset. And we're doing that thanks to the experience that comes from more than 40 projects that we delivered over since the inception of Unit8. And we're also doing that thanks to the digital native crew that we've collected. Unit8 is right now about 40 team members strong, again delivering the AI and data services, mostly in Switzerland, but also on pan-European basis as well. Jumping in to the topic of today, improving OEE in manufacturing space thanks to advanced analytics and data science. We'll try to actually segment this session into three areas. So at first, I'll cover at the high level the methodology that we're usually leveraging in the production line optimization projects. And we, of course, want to show you some real life scenarios. That's why Tomek will actually show you some of the work that we're doing. He'll show you several of the use cases that we have, and the types of the optimizations that we're finding, the types of the opportunities that we found on the journey. We'll close the session with some of the key learnings, some of the recommendations that we have for you, should you be interested to start your journey into production optimization, leveraging data science and AI. By the way, this session is for you, so please feel free to use the question tab in the control panel to ask any questions. We have, apart from myself and Tomek, we have Samir here as well, who's our magical organizer of the webinars, who will help to get the questions answered towards the end of the webinar. And if you're here at the webinar, you probably are interested in improving your OEE in the manufacturing sector. And before we tackle, let's say, how can you use data and AI, I think it's quite important to understand what drives the productivity of the factory down. What could be those key factors? And I'll make a small disclaimer here. Neither myself nor Tomek are manufacturing professionals, but actually the data and AI professionals who are helping the manufacturing companies to solve the types of the problems that we will be discussing. Therefore, potentially our take might be a little bit simplified, but yet the work that we have done and the methodologies that we've been using are actually helping our customers to significantly improve the OEE. To continue, if you think broadly about the overall equipment effectiveness, there's a couple of key factors that can lower that KPI down. So we're speaking here about the availability loss, the things like the equipment failure, the availability loss related to setup and adjustments, but likewise, the big factor is also the performance loss. So the minor stops that can occur, or the idle time between the stops. At the same time, you can see things that are slowing down the production and actually making it run on the reduced speed. And we also have the attributes related to quality loss, like, for example, the process defects or the reduced yield of the products. And as you can imagine, this actually means several things for your operations. It means some unplanned stops. It means some additional idle times. It can mean some slower cycles and some rejected goods. All of that actually contributes to bringing the OEE down and resulting in suboptimal performance of the production line. So how can AI come into play? How can data science help here? So throughout the last years, we've actually gained some experience, and we believe that the optimization of the production line, leveraging data science and AI, can actually help, first of all, understand why some of those symptoms are happening. Why is there the idle time? Why is there the some additional small stoppage that were not predicted? And once you understand, it's actually much easier to, for example, predict some of the stops, or maybe even prevent some of the stops. It can help you understand why some of the idle times exist. Maybe there's a way to actually using the data-driven approach to suggest the improvements, like reordering or resequencing some of the actions. And using the data, we can also figure out why the speed of the production is actually deteriorating. And I think we'll be showing some of the examples later on in this webinar. And likewise, we can use data to figure out what could be the reasons for rejections of the goods related to the quality, and is there anything that we can actually do about it to improve it. So as I mentioned, we do believe that the data science and AI comes with some extra value proposition to the manufacturing sector. And if you're looking to start a project in the area, what's the best method to do that, right? What's the way to start? And as with any business project that you're looking to start with the problem, right? Start where the pain is. Start where you have a business problem that's impacting your operations. But at the same time, aim for the impact, right? The process of collecting the data, the process of data-driven analytics in the manufacturing space is time-consuming. So make sure that you pick actually the problem that can provide you with significant enough of the impact. And here are some of the problem statements that we've seen from our customers over the last few years that we've been on the market. So as an example, we've been working with one of the chemical producers who had issues with being able to recognize why the production is slowing down. We've been working with with one of the top pharma producers as well, who actually was running out of the production capacity and was looking for data and AI to actually squeeze out a few % of the productivity so that they don't need to make a significant capex investment. And we've been also investigating a few other scenarios where we've been trying to understand with the data why the defect levels of a certain manufacturer are increasing. So those would be the type of the problem statements that you should be looking at, because there's still quite a lot of hype on the market with regards to data science and AI. And we want to ensure that when you start the project, you really aim for the true business problem, aim for the impact. And in order to do that, try to also set your goals in a smart way. And what I mean by that, smart way means specific, measurable, achievable, and time bound, which basically means that try to set up the goal where you can actually use the data, you can measure the impact, and give it, let's say, the time bound to perform it. And once you've actually selected the project that you want to tackle, make sure that you do some verification before you move on to conducting the project. First of all, verify if actually the project is solvable with data, right? So in order to run any type of the data science advanced analytics project, you need the data. So ask yourself a few questions like, what's the data that you need? Do you actually have that data? If so, where is it stored? In what format? Is it digitized? Because in several manufacturing sectors, still a lot of data is actually in paper, right? So before you can actually run any advanced analytics, there needs to be a way to digitize it. And at the same time, really look into the projects that are bringing, or at least looking to bring, the positive ROI. So think about a simple metrics of the impact that the project can bring and the effort that you need to put in order to conduct the project. As Unit8, we've been using different techniques to actually help our customers ensure that we're picking the right projects, the projects that can move the needle, and the projects that can actually return on positive ROI. Some of the techniques that you see on the right-hand side are part of our advisory, where we're actually working hand in hand and partnering with our customers to identify if the problem that they have can be solved with data science. I'm not going to be talking about those techniques today during this webinar, but I'll be actually having a webinar in 2 weeks purely related to picking the right AI project, especially when you're embarking on the journey with AI. And throughout our history of working in the manufacturing sector, we've developed a certain structured approach to production optimization. And it's not rocket science, it's not the methodology, but it's a methodology that has proven itself for us and our customers over the last few years. And it led us to actually helping the customers drive OEE by 10-15%. So I'm going to give you, I would say, a snapshot of that methodology, and Tomek later on will show you the real life examples. And as any type of the project related to data science and AI in the manufacturing space, it actually starts with the business understanding and data understanding. So that phase of the project, I actually usually say that we're turning a little bit into a sponge, right? We're trying to absorb as much knowledge as possible. We try to collect the data, we're trying to understand the process, and what's also very important, we're trying to take the inputs from the experts, from the subject matter experts, in order to understand what might be the focus areas for that particular project. Once we've done that, we'll start seeing actually two things. We're starting to see the inputs from the experts, and we're also seeing the data speaking to us, letting us know which areas of the production should become our focus areas. And then based on the variability in that process, we're picking the areas which will become the focus areas for our projects. And as we understand more about our customer business, and as we understand more the data that we've been provided, we're actually building a set of, you can call them levers, you can call them improvements, you can call them the hypothesis of improvements, and we're actually building a list, usually anywhere between 20 and 40 different opportunities that we have for the improvements. Again, as I mentioned at the very beginning, it's always important to ensure that we're picking the right things to focus on. That's why a prioritization based on the impact and the possible effort is actually quite important to help us prioritize the things we should be focusing on. And once we have the list of the hypotheses, the levers, we do want to run the in-depth analysis on those opportunities. And again, Tomek will show you in examples what does it actually mean. And once we had an opportunity, we've actually proven it with the data, we verified it with the experts, we go, of course, into the implementation and the change management to ensure that we meet the goal that was set by our customers. feel free to ask any questions about the methodology in the Q&A panel. And we're going to give you 2 quick examples of the projects that we've been delivering over the last years. And the first one is actually with the Swiss global chemical producer that again was struggling to understand why the performance of the factory was deteriorating, why the production was actually slowing down and it was suboptimal. So we've been invited to actually join effort with the customer, and as per the methodology that we've mentioned, we built a solution that was able to understand the process, that was able to collect the data, and it can be data from the machines themselves, from the sensors, from the HVAC system, and to understand where are the anomalies, right? How come the performance of the factory was actually deteriorating? And we're using, of course, different technologies like stream processing, like trend prediction, trend monitoring, the outlier detections, anomaly detections. In this particular case, and I think Tomek will also mention about it, we've actually did manage to find relatively simple to fix things that were slowing down the entire production, and we managed to create the implementation plan and the suggestion plan of the implementations, which the customer has implemented, which actually resulted in a 15% of the increase of the productivity on that particular production line. Another example of the engagement that we've been having comes actually from the pharma manufacturing sector. And in this particular case, our customer was actually at capacity for the particular production line. So they've been actually they were having a dilemma. Should we be investing in the brand new production line, or can we actually still leverage the existing line and maximize the potential coming out of it? So we did set the goal of increasing production capacity by about 5% via data science and advanced analytics, and we followed the methodology that I've mentioned to you. We came back to our customer with about 40 different opportunities that we've seen thanks to the data, and throughout the discussions and the vetting with the subject matter experts, we've actually picked less than 10 for implementation, and yet they've actually turned into a massive business benefits for the customer, as we've managed to achieve about 10% of the productivity increase, both in the throughput area and the yield optimization. So those are a little bit of the teasers of the types of the projects that we do, and I'll actually pass the floor to Tomek to give you a step-by-step preview into how we're tackling the data-driven projects in the manufacturing space. Tomek, the floor is yours now.
Okay, thank you, Kamil. So I'm waiting for you to give me control, and I'll start sharing.
Perfect. Can you confirm that you can that you're able to share?
Yes. Okay. I cannot hear you anymore. Can you hear me?
Yes, we can.
Okay, great. All right, so let's kick off. Once again, my name is Tomek. I'm an engagement director at Unit8, and I'll take you through production optimization step-by-step slides. All right, so we'll take you through a project that we have done for one of our clients. The problem is that one of the production lines that belongs to the client is reaching its maximum capacity. The client contacts us to ask about what we can do using data, advanced analytics, and AI to optimize the factory. So what we usually do in cases like that, we start with a conversation with the client. So in this case, we organize a meeting with our client And our goal there is to learn as much as we can. So we are in an intake phase. We want to get as many inputs as possible. And among them are things like understanding how the factory operates. What are the roles of different people? What are the questions they're asking? What is the production flow? And what are the data assets that are gathered on the production line? So we start on the day one of our journey, and on the slides I'm going to be taking you through what happens through the duration of the project. And we start with this intake session, and we go visit the factory. So on the right hand side you have Unit8, and on the left hand side you have some stakeholders on the factory side. And as we go into the meeting, we quickly realize that people have different perspectives and they ask different questions, which is understandable. So CFO may ask the question, do I need to invest in a new factory, or can I fulfill my demand with what we have? Head of production may want to know why there's some delays and pauses in production, and why some customers are waiting longer than expected for their orders. Shift engineer would have a slightly more technical perspective, and we would want to know if the equipment is running at full capacity, for example. But these are just some of the views. Typically, we find out that there are around 15 to 20 stakeholders asking different questions, and it's important to try to take all of those questions into account when thinking about the solution. So that's why on the first stages we run interviews to try to get this 360-degree overview of the problem. And the next thing we focus on is business and process understanding. So in this case, and in many other cases, as the product optimization of production line is what we're doing, we start with the line itself. So here you can see a picture of this particular production line. And from the top, you can see some needles or syringes that are hanging off the ceilings, and they are used to pour substance to a container that is moving through the production line on a moving scale. The moving scale is in the middle. It's a little bit blurred here to hide the labels, but this is where the container is, and this process is called compounding. And in this particular factory, there are multiple lines like that, and they are responsible for producing different types of materials and products. The owner of this factory actually has a couple like that. This is by far the largest, and it's responsible for production of tens of millions worth of products. From that, we create a simplified view of a production line. So this is what you see on the screen here, and again, you can see from the top some valves that are pouring the substance into a moving scale, and again, this process is called compounding. But there are some other steps of the process here as well. Right? At some stages, substance has to be mixed, or maybe in some parts of the production line, there is a drying process that has to take place. So in fact, as I will show on the next slide, the reality is a bit more complex. And in this production cycle, there are three possible outcomes. Everything can be okay, which is the green arrow. Obviously, this is what we are aiming for. But it's also possible that during the production process, we will figure out that the end product doesn't conform to the quality specification and has to be accounted as a waste. This happens, for example, if you dry the substance too much and it becomes and then it spoils the end product. So obviously, this is something we want to avoid. And the third possible outcome is something that we call a rework. So that means that the end product doesn't meet the specification, but it's something that can be fixed. So maybe not enough of some substance has been poured on the line. And in that case, the scale is moving back under a certain valve, and additional amount of substance is added. And then there is a weighing process, and everything needs to be checked. And then you may recover from rework to okay. But obviously, that's additional time that needs to be invested in this, and this is again something that we want to avoid. So in all cases, we're aiming for okay. Of course, as I mentioned, the reality is a bit more complex. So here we are showing a detailed process map of what's happening on the line. It's blurred to hide some of the sensitive information that belong to the client. But the idea here is to visualize how many steps we're talking about here. What we're also showing here are the blue dots in a couple of areas of the flow, and they represent data assets. And as we are in the business of data analysis and data science, these are of course very important for us. We want to have a look at them. So that brings us to another focus area in the intake sessions, and that's data understanding and finding out where is the data. So here we're looking again at the production line, but as we start zooming into different areas of the production process, we see different data assets appearing. So those individual icons that are highlighting on various parts of the screen may look familiar to you. They represent different technologies that are used to store the data on different parts of the production process. But what it shows us as well is that this production line is not a single uniform source of data. There's not one place that you can connect to get the full overview of what's happening on the production line. Actually, it's quite the opposite. Each part of the production line has its own distinct data source that is designed to fulfill needs of that particular production step. And it just happens that advanced analytics is rarely one of those original use cases for those data sources. And this is why those technologies, those data sources are locked in silos, and those I hope those icons that I'm showing resemble silos just a bit, but it's a visual representation of the fact that the data is locked and close to individual parts of the production line. So what it actually means? So it means that if we want to start analyzing what's happening on the production line, we run into a situation where we need to ask individual teams that are responsible for parts of the process to give us access to the data. And it just happens that they usually do this by exporting Excel spreadsheets and sending them over. Now, Excel is a great tool. There's nothing wrong with it. It's very good for some specific use cases. But we found that it's not the best tool to do real-time analysis of the production line or to do advanced analytics projects. And that highlights our first focus area of the project that we are going through. And this is in fact true for the other projects that we've been doing. And this is unlock this silo space, right? So what we're trying to achieve here, and this is the main focus of the first weeks of the engagement, is actually unlocking the silos. So we want to create an environment where we have where we can analyze data in a comfortable way. And for this, we introduce a lightweight and modern stack of technologies It covers areas such as data transformation, analytics, data storage, and runtime scheduling or orchestration. So once we have that, we can start focusing on looking for actual improvement. And this brings us to another section, which is finding the focused areas and the topic of variability. The picture that you see here is a slightly more detailed version of what Kamil was showing, but it's basically a visualization of the approach, of the structural approach that we have towards finding ideas and optimizations and selecting the ones to focus on, and then moving to implementation. So we usually at early stages of a project like that, actually on the inception phase, so on the first meeting, we also interview people, and that usually allows us to already form a couple of hypotheses. So experts on the factory usually already have some ideas of what could be improved on the production line. So in this case, we started off with 10 to 15 ideas that we also put levers. But as we're building our data infrastructure and as we start looking at the data, we are getting into a situation where we can let the data speak to us as well. So that's another source of insights and ideas for optimization. And those two sources combined take us to a list of around 20, 40 different ideas or levers that we can consider to improve the state of the production line. And in order to be able to efficiently navigate through that list, pick the right candidates, to pick the priorities, we need a framework like that, and we need to assess the different ideas on the different dimensions like impact and effort, and based on that we can select areas of focus, and that's the essence of the structure approach here. So once we have levers, we then can move to something that's that's quite common, a lean methodology of working with the levers. So we start with the idea, the lever, then we go to a data analysis modeling phase to figure out how exactly we can make changes on the production line to have some benefits. Then we run some tests, or we either do some simulations or run tests directly on the production line, and then we measure impact, and then we learn from it and adjust, and this is our lean cycle. So this is how we usually work. And now fast forward to week number 16. So the time passes, and we have already learned a lot about the levers and the potential improvements, and we can roughly put them in two main categories. One is predictive maintenance. So these types of improvements help us save time by predicting abnormal conditions before they actually occur, and apply some preventive measures so nothing bad happens, and we don't have unexpected production stops. Another category is something that we call adaptive production. So this is a category of improvements where you use the data, advanced analytics, machine learning, build some models in order to adapt the production process or change something in production process to make it more efficient. And I'll be showing a couple of examples of that. But what we were also able to build in those in the first stages of the project, in those 16 weeks, is often overlooked, but it's also quite important, is the end-to-end data integration. So we are able to unlock the silos, connect the dots, put all the data sources together. And this is also something that will be beneficial for the clients in the future. So we use it for our analysis, but the client also will benefit from that to be able to do additional ad hoc analysis on what's happening on the production line. So this is always an important asset and outcome of a project like that, the end-to-end data integration. Okay, so now let's move into levers, some examples of levers and improvement opportunities. So we'll start with an example that that shows benefits of full process visibility. So before I explain what's happening here, let me just mention that the factory that we're talking about is it's not 100% automatic. There are teams of operators that overlook the production and actually perform some manual steps now and then, and they are working on shift basis, and they are forming teams. So the first benefit from full visibility of the production process that we gained by unlocking those data silos was finding out that basically some teams perform better than the other teams, and we're also able to figure out that in this case, team number 4, which is performing the best, has a unique way of operating. They perform some steps slightly differently than all the other teams, which makes them quite effective. So we use this opportunity, we use this knowledge, and we go to other teams, team number 1, 2, and 3, and we figure out the optimal way of working for all of the teams, and all the teams adopt this way of working, and in the end we end up with a situation where all the teams are performing on a similar level, and that itself allows us to save tens of hours over a period of a year. So this is quite simple, but already impactful example of what you can gain by having full process visibility. Another example in this category is it's shown here, and here the idea is that the process consists of different steps. So you have step number 2, step number 1, step number 2, and step number 3, and they are running in some orders. Furthermore, you can have multiple production cycles that are overlapping with each other because there is some degree of parallelism on the production line. And again, by having the full visibility of the process, we were able to figure out that step number 2 is a bottleneck. Furthermore, we also see that if we were able to reduce the time of step number 2, there's enough room or time that we have around steps number 1 and 3 to actually benefit from reducing the time of step number 2, and that highlights our focus area. So then we go to experts and we say, okay, so what can we do to reduce the time of step number 2? Because we see that it's a bottleneck, and if we do something here, then we have good benefits. And in this case, it actually turned out that there is some additional equipment or different type of equipment that can be installed in the machine that's responsible for step number 2, and therefore reduce the time quite significantly. And this change has never been done before because it was not clear before having the full visibility that reducing this step is the bottleneck, and is actually something that should be area of focus. So here, again, a quite simple insight from having full visibility of the process, and the change on the production line resulted in actually multiple days of savings. So that was quite significant improvement on the production line. All right, so the next slightly more advanced example is the one of reducing the time of drying. So just quickly, one of the part of the production process is called drying, and the idea is that you need to reduce the moisture content of some substance, and you use microwave generators to do this. And this is a circular process where you dry for a certain amount of time, dry a bit more, check the moisture content, which is time-consuming part, and then if your moisture content is not okay, you do reduce step number 2, check the moisture content again, and this and you have this loop. And once you get to the right moisture content, you can proceed to another step. And this means that often this drying step is repeated, and it results in a loss of time. So what we're trying to do is we're trying to understand a bit the drying process and see what is influencing the moisture content, and we find out that there are 3 key ingredients here, or parameters here: the ingredients data, process data, and weather data. And that insight allows us to. So we obviously want to be able to figure out when to stop the process at the right moment, so that the moisture content is at the right level. An obvious choice would be to have some moisture content sensor, but we don't have this at hand. So we're looking for other way to find this, and we figure out that by looking at the temperature profile of the drying, we can pinpoint the area which is highlighted in green here that gives us the best outcome. And I know I'm a bit running out of time, so I'll just run quickly through it. So what we can do in the end is to train a machine learning model that tells us what exactly is that endpoint. And this is just one graph that shows how this model is performing, some preview of insights of this project. And we can then incorporate this machine learning model into the drying process, so that we no longer base our drying on time, but we base it on an endpoint, and we're sure when we at the end of step number 2 that the moisture content is right. What's the result of it? Is the reduction of average duration by 23%. So I'll just fast forward maybe and skip those slides, and maybe just let's talk about the overall outcome. This is what Kamil mentioned already. So all those improvements combined allow us to improve overall efficiency by 50% at week number 28. So we are quite proud of this outcome, and a couple of key takeaways and lessons learned here. So one is make friends, have good cooperation with the local team. The other is listen to SMEs and challenge them, but use the data to challenge them. Don't just challenge them like that. Be pragmatic. Don't underestimate the implementation part, because even the best ideas, if they're impact, you can't implement them. Leverage the cloud. It's usually quite helpful for us, and change management is the key. So it's actually the key to the success of any project like that. I will now hand over to Camille for some final thoughts.
Thanks, Tomek. Thanks, Tomek, actually for showing us the kind of step-by-step how we collect the data, how we try to understand the process, how we build the list of the potential improvements and opportunities, and then how they actually contribute to the big impact that we can put on the OEE of our customers. I guess a key takeaway in here is that the data science and AI are definitely reaching scale in the production manufacturing environment. And I think we're definitely beyond the hype phase. The AI and data science is actually bringing some very tangible business impact and tangible business benefits in this space, right? And we've shown you a few examples of how we've helped our customers drive the OEE anywhere between 10 to 20% up. But in order for you to leverage the impact, and Tomek, maybe I'll ask you to fast forward the animations. You need to do a few things in order to realize the impact. So first of all, as Tomek was showing, you need to break the data and the organizational silos that you have in the organization. And therefore you actually need to start treating the data as your business asset, right? You also need to ensure that you pick the right problem. You verify if that problem is solvable with data science. You don't kind of overinflate some of the expectations that there's some magic going to happen, but AI and data is there to actually give you the insights that will help you make smarter decisions. Definitely an important factor is the talent. Either in-house or by partnering with companies like us, make sure that you have that talent that can help you move the needle. And something that Tomek already alluded to, there's a lot of the advantage in the speed of the deployments of the AI-related projects if you decide to use the cloud infrastructure. So here are some of our lessons learned. Here are some of our key takeaways and recommendations for you should you decide to embark on that journey. And we slightly ran over time, but I think we have maybe time for one or two questions. For the rest, we'll answer offline. So Samira, are there any questions waiting for us?
Yes, and one of them is from Daniel, who unfortunately had to leave. So I hope he'll be listening to that recording so that he have the answer. He was wondering whether we had also used the crisp DM approach, or whether our approach was similar to that crisp DM.
Yeah, okay, good question, because there's actually quite a lot of resemblance. So the crisp, for those of you who are new to crisp DM, that's the cross-industry standard process for data mining. And our process is somewhat similar, maybe with some small deviations that we've made throughout the time to gear our methodology towards the manufacturing sector. But the beginning of the process are definitely the same: the business understanding, the data understanding, and that type of ongoing iterations to find the right answers. So I would say with using our version, let's say, slightly modified of crisp DM, but with definitely using that method for some of the other projects that we're running as well. Maybe last one, Samir?
Yes, and that question was about the biggest challenges we had in the example project we shown. So since we're running out of time, I suggest that we focus on the one biggest challenge we've had on that project.
Okay,
so handle this one.
Answer this one. So as I mentioned a bit earlier in the key takeaways, I think one of the key challenges was around the change management and actual implementation of changes. If I were to pick the top challenge, and this is because it's usually hard to move from data world into a reality of a real production line. And it's often that you find something interesting in the data, you find some key insights, but actually turning them into something that's running on the production line and has real impact requires going from the domain of data into the domain of the actual manufacturing process. So therefore, the change management is really key here. Having the right SMEs on the side of the team that's working with the data, having the right buy-in on the factory side is important. With the right team and right approach, it's much easier to actually implement the insights that come from the data.
Perfect. So Samuel, maybe we'll promise to our audience that for the other questions that are still in the pipeline, we'll answer offline, as we want to ensure that we stay committed to the original duration of the webinar. With that, we wanted to say a big thank you for joining us for this session. We're hoping that it has been insightful. And at the same time, we are inviting you already for the next webinar in 2 weeks. We'll be actually focusing on finding how to pick your first AI project, what's the right methodology to assess whether or not the project that you have in mind is the right one. With that, thanks a lot. Have a great rest of the day, and looking forward to seeing you on the next sessions.
Thank you very much.